Okay. It looks like now I am actually live. That was good. I just did the first 3 minutes of my presentation and forgot to hit the Go Live button. Doing these live streams, there are so many buttons to push and levers to pull and push that just forgetting one is a it brings the whole thing crashing down. Anyway, as I was saying, the setup that I'm going to be using tonight is a 6-inch f4 imaging Newtonian. It's a reflector telescope riding on a Celestron AltAz Evolution AltAz mount. That's on a Celestron HD Wedge, riding on my cinder block pier here, and that's what's going to be swinging us around and pointing the camera at all the different locations that we're going to be checking out tonight. And we will be continuing our galaxy quest across the area of the sky between the Big Dipper and Leo and Virgo, and continuing to march across there with all of the wonderful galaxies that are up there. Now the first part that you also didn't hear was hello from Eastern California, the Death Valley region. We're having another gorgeous, warm, calm evening, which is just wonderful in the spring. We're having some beautiful spring weather here, getting up into about 90 degrees, low 90s or so. And so starting to get a little bit warm, not too warm yet, but just kind of gorgeous weather for us right now. By next month, it'll be triple digits and it'll be a different story, but for now it's pretty darn nice. So let's go take a look at where we are at. Right now I happen to be focused on Denebula, which is the tail star in the constellation of Leo, Lion, and the Big Dipper is over here, and Virgo is down here, and you can see all these nice little red and orange and blue ovals that are in here that are all this rich galaxy field that we've been working our way across the last few nights. So we're going to continue doing that. And in fact, along those lines, we have a running list of all the ones we've seen so far, which has been quite a few that we've seen in the three sessions that we've done to this point. So now we get to highlight, okay, so we've done a good 3/4 of this field. So that's a nice thing. So I think what I'll do tonight is we'll just start up here on Leo, and let's see, let's start and work our way back. That one is pretty small. That one's very small. And that one's pretty small. I think we're just going to start in here with these guys down here. So let's do 3338. Send our scope over to that, and let's turn our sequencer on to help us find that next target. There we go. And actually, yeah, it's right in here. I can see just a faint little fuzzy thing in there. Yeah, these little, almost like a little house shape with a galaxy being down here is that little house shape right there. So yeah, let's take a look at this real quick. This might be a little small, but we'll try seeing what we can see. We're gonna do, right after we do this one, we're gonna do some a couple of groups of galaxies that are pretty large and spectacular. So but this one, I don't know that I've imaged this one before, so I thought I'd take a quick look at this first to see what if anything we've got in here. And it looks like, yeah, it looks like, well, I don't know, hard to tell. I don't think that's a picture of the actual galaxy in Stellarium. So we'll have to see what we get on here first. But while that's doing that, NGC 3338, NGC 3338. Well, we got a 3384 here, but I don't think that's the same thing. Looks like there is no Ooh, it's a nice little, oh, look at the nice little shape on this though. Actually, this one's kind of sweet. So maybe we will spend a little time on this. Yeah, let's fold you out of the way. Maybe we will spend a little time on you because you are just a sweet little shape on there. Got some nice spiral arms coming out, fairly uniform. Oh, and look down here, we've got another galaxy down here, another little one there, another little smudge there. Definitely a very rich area of the sky for these kinds of things. Alright, let me go make sure I've got my enhancements on, which I don't. So we need to make sure we do that. And back that off just a tiny bit till we get some more data in so we're not completely blown out there. NGC 3338. But Wikipedia does not seem to have an entry for it. Let's just try doing a general NGC. Try doing a general Google search for it. Sometimes we come up with other. Copernic.org. The Sky Alive. Well, it's 57 million light years away. Size, classification. Okay. Had more information on this. It lies at a distance of 57 million, so almost 60 million light years away. It's about 83,000 light years across, or about half the size of our own Milky Way galaxy. Really. My understanding was our galaxy was about 100 to 120,000 light years. Anyway. So, yeah, it's a bit smaller than the Milky Way, but 60 million light years away. So we're seeing it as one would see it, would have seen it 60 million light years, 60 million years ago. So, and in fact, well, let's turn the background music back on. Yeah. So we got some of that going on while we wait for our data to load here. Let's hope our internet connection is a bit more stable tonight than last night. Last night it was mostly okay, but there were definitely moments where it was dropping out on me. So the audio last night was definitely cutting in and out here and there were little gaps and blips and things. So thing about living in the middle of the desert, it's we do have our challenges with technology, but considering where I live, I have surprisingly good internet that I can actually live stream at 720p from out here. It's actually quite surprising. Hi Dennis, glad your skies are clear here in northern Colorado. We are jealous. Yeah, well, the reason I'm doing the doing 2 nights in a row of live streaming is because my next couple of nights are not looking so good. Although forecasts are always changing, so who knows. But yeah, I can definitely relate. Before last night, I had to wait almost a week. I think it was Friday and Saturday of last week that I did back-to-backers, because the entire rest of the week was high, thin, monsoony-ish clouds that just keep blocking the stuff we want to see. So last night and tonight again are back-to-back. Tomorrow night I know is not going to be good. As for the rest of the week, we'll have to see as we go. but forecasts are always changing, so who knows. It's looking like right now I'm definitely not going to be doing much tomorrow night. And tomorrow is the new moon, so we only have probably till about Tuesday or Wednesday nights where there will be dark enough sky without moon to keep going. Oop, and we got photobombed. Satellite trail right through there. So, I don't know, we might have another night coming up this week, maybe. Another one, last shot, perhaps. We'll have to see. But, you never know. Here in the desert, we tend to get more clear weather than cloudy. But, we're still not free of it all. Although this year we've gotten so little cloud because we've gotten no rain. This winter I think we had 2 rain showers and that was it for the entire winter, which even for us here in the desert is a drought. That's pretty darn dry. We have literally no flowers out here in the desert this spring. And I've lived out here now, I think this is my 6th year, my 6th spring out here. And never had a year where there were no flowers at all. And this year there were no flowers at all. We did not get any fall rains, we did not get any spring rains, and winter was very, very few. So, very little. So it was not real good. But we got some clear weather, so I got to do some astronomy sessions, so I guess there's a silver lining in that non-cloud. But this is a pretty little galaxy. There's no doubt. That is a pretty little dude right there. And we got some nice other little things down here too. There's another little galaxy group right in here. That one's kind of interesting. It's hard to tell what that is. That does not look like a star in the foreground of a galaxy. It looks like a bright core and some sort of, I don't know, that may be an active galaxy that's being pulled out of shape by another nearby galaxy, where all the tail, the arms are pulled off to one side. And we could just be looking at it at the side too, I suppose, but that's a very interesting looking shape down there. This one, however, is a nice uniform little spiral. That's kind of a sweet one. That is kind of a sweet guy right up there. Nice shape on that. Let's mark you as done. And then we'll figure out where we're going next. So now I think we're going to be going down here and doing 95, 96, and 3384. I don't know that it's unlikely I'm going to be able to get all 3 in the same image frame. I can try. Likely we're only going to be able to do 2 out of 3 at a time. But we'll have to see. But pulling up to our 10th minute here of data on 3338. And there we are. Really nice little galaxy group down here too. That's cool. What's going on up here? Not sure what's going on up there. Little star cluster or something there? Oh, another satellite photo bombing through. So, very pretty little galaxy, and a nice little galaxy group next to it too. But, moving on. Yeah, let's see. I don't think I'm going to be able to get all 3 of these. But let's try swinging down here and see what we can get. let's see what we can see. Yeah, I don't think I'm going to be able to get all three. I'm probably going to have to do... Yeah, let's just go over to here and do 95 and 96 together, and then we'll come over and do 105 and 3384. Yeah, there's one and there's the other. Okay, so there's the two of them right there. So let's, in fact, yeah, I'm just gonna just do it right there. That's good enough. Okay. So this is M95 and M96 that we are going to do. And of course my view is, let's see, I think it's like this. Because the way the mount twirls the scope around, sometimes the scope is upside down, sometimes it's right side up. For a lot of the stuff that we've been doing that was closer to the Big Dipper, the scope was actually upside down, so I have to invert and flip this image in the planetarium to match what my scope is seeing. In this case, I think it's just going to be this 95 and 96 is going to be like this. But we'll know here in about 10 seconds. Dennis, are you still having trouble hearing me? I appear to be live over here, so let me know if you're having trouble hearing me still. But everything seems to be working correctly at my end. Okay, so there is M95 and 96. And so, yes, that is correct. Well, no, actually, no. That right there is 95. I think so. I think we're actually... little triangle of... I'm pretty sure... Gosh, it's tough to tell. Okay, so there should be a couple of these stars off. Is that that? Okay, let me turn the flipping and the inverting off. Okay, so that should be I'm all turned around. I don't know which one is which. I can't actually tell. So that should be, these two stars here should be close. Is that these two? I think that's these two. And then this little triangle is just outside it, which is this little triangle, yeah. So this here is 95. So I think all I need to do is flip it vertically. And that, this I think is it. And I think this, so this is 95 and this is 96. Pretty sure that's right. In any event, these are a couple of Messier objects that are pretty cool things to see. Okay, good, Dennis. Thanks for letting me know. I didn't see anything drop at my end, including my monitoring of the feed, so I'm not sure what happened there, but I think I was... in this case, I don't think it was me. Usually it is me. Usually something's out. My microphone shuts off or mutes and I don't even realize it, or typically my internet signal goes wonky for a few seconds, so you never know. And we are photobombed by another satellite. That's pretty sweet. 95 is a pretty nice. It's got such a, it's an obvious bar, and it's got such a great inner ring of stars, and then the outer wispy arms as well. It's a great shape. 96 is more of a, it's more of a blobby thing. It's got a nice shape too, but it seems to be a bit brighter, so it's more blown out. So to see it, you kind of have to see. So once I back way off on the stretch, then you can start to see its features a little bit better. But I think it probably will. Let me see how it comes across on the feed here, but I think it probably dims it down a little too much for you guys. Yeah, let me bring it back just a little bit. But it's so much brighter than 95 that have to really dim it a little bit to see the inner structure, otherwise it just, the whole core just blows out. But they're both, I mean, they're almost identical, really. They're almost identical. But 96 just seems to be a little bit brighter. Whereas 95 is a little bit rounder. There's a little bit more detail to its shape. Couple of beauties though. And guess who forgot to unmute his mic? So for those just joining us, we're doing M95 and M96 here, which are, as I was showing there, just under the belly of the constellation of Leo the Lion. That's Leo there. And so we're going to be doing this group, and then this group, and then moving back down into our galaxy field. And I have this flipped so we match what the scope is seeing. Just coming up on our 10th minute here with these two beautiful galaxies. Let's see what M95 M96 is about 30 million light years. M95 is about 32. So they're both in the 30 to 35 million light year range away. They're probably companions. Floating out through the universe together. Alright, and there's 10 minutes. 10 minutes with those two beauties, M95 and M96. Okay. So now we'll head to 105. And we'll do these two. Yeah, 105, there they are right there. And we'll make sure the scope has, the mount has settled. And then we will start our image. Okay. And we'll head over to you. So M105 and 3384. Let's see. SCA 105 there. Also known as NGC 3379 is an elliptical galaxy about 37 million light years away. So it's just going to be a regular little elliptical. Yeah, we're going to have looks like a few little galaxies in here. Not surprisingly. Almost every galaxy we've looked at has had a few other galaxies somewhere in the image with it. Yeah. There's those. Well, there's a interesting trio of its own right there, huh? Yep, there's another little one over here. Alright. And they're look like they're just going to be regular ellipticals. This one here looks like it might have some detail in it. We might look up and see what that is. But this is a regular elliptical galaxy is not going to have a whole lot of detail, so it won't be nearly as interesting to see as 95 and 96 are, where they had their nice rings and spiral arms separate from the core. Elliptical galaxies tend to be a bright core and a fuzzball of stars, and generally not a whole lot more to see than that. In fact, I'm looking at the Hubble image of M105, this one down here, and it's basically just a bright fuzzball. But it's an elliptical galaxy 37 million light years away. It was discovered by Pierre Machin in 1781, just a few days after he discovered M95 and 96. This galaxy is one of a few not object verified by Messier, so omitted in the editions of his catalog of his era. It was appended when Helen S. Hogg found a letter by Machin locating and describing this object, which matched those aspects under his first published name, NGC 3379. It's a standard elliptical galaxy with a flattening of 10%. The major axis is aligned along a position angle of 71 degrees. Isophotes of the galaxy are near perfect ellipses, twisting no more than 5 degrees out of alignment with change in ellipticity of no more than 0.06, blah blah blah. There is no fine structure apparent in the isophotes, such as ripples. Observation of giant stars in the halo indicate there are two general populations, a dominant metal-rich subpopulation and a weaker metal-poor group. Okay. This one actually is the most interesting. Let's see if I can get a 3389. Okay. 3389. Let's see what 33 is. Is there 3389 in here? Well, no, its companion here is a barred lenticular galaxy 3384. Okay. It's surrounded by a giant ring of neutral hydrogen. It's one of several galaxies within the M96 group, also known as the Leo 1 group. A group of galaxies in the constellation Leo. Okay, yeah. But what about 3389? I did have that right? I did say it was 3389? 3389. Does not seem to be in. Does not seem to be in Wikipedia. Okay. Too bad, it's the most interesting looking one of the group. But these are just going to be... In fact, we're probably just not even going to spend more than another minute here on this. We'll let this sub-exposure finish and probably move on. Ellipticals really aren't terribly interesting to take a look at. So, we'll probably just move along here. Yeah, in fact, there's not much more we're going to see. Except for this little guy here. This one here could be interesting. But these other guys, But I think we're just going to move along. Let's go out. Okay. Alright, so let's add that, and add that, and add 3389. Add them all, highlight them all, moving on. Okay, and we need to reflip this so we're oriented in the right direction. Oh, and I forgot to add these, because we certainly saw those. Add, highlight, done. Okay, so those are all done. So now let's head down here. And to head down here, we're gonna... Let's move on down to this one. And then we will do the Leo trio, which is this down here next. Yeah, there it is right there. Okay, so... Start imaging. See how this works with just this guy. This is again about 35 million light years away. These is NGC 3593. Let's see. NGC 3593. 593. There we are. It's a lenticular galaxy in Leo. It has a morphological aspect which indicates it is a lenticular galaxy of the pure spiral type. This is a starburst galaxy, which means it is forming new stars at a high rate. This is occurring in a band of gas surrounding the central nucleus. There is a single arm which spirals outward from this ring. It's a little guy. It is frequently but not consistently identified as a member of the Leo triplet group. This galaxy is known to contain two counter-rotating populations of stars. One set of stars is rotating in the opposite direction. That is, one set of stars is rotating in the opposite direction with respect to the other. One means for this to occur is by acquiring gas from an external source, which then undergoes star formation. An alternative is by a merger with a second galaxy. Neither scenario has been ruled out. The age of the lower mass counter-rotating population is younger by about 1.6 or so billion years than the primary star population of the galaxy. 1.6 giga years is how they have it written in Wikipedia, which is kind of funny. Giga years. Well, that was a good sneeze. I think while this builds in for a minute, I'm going to go get a tissue and blow my nose. Be right back. Okay, coming up on our 5th minute of data on this guy. I think that's probably what we'll do, is we'll do 5. I'm not seeing much in the way of detail on this. The Hubble has a fairly decent image of it, but it takes more resolution than I think we're going to get on my camera, so I think that's probably about... Definitely got a nice core, a little gap between the core and the rest of it, but I don't think we're going to see a whole lot more other than that out of this one. So let's just move right on to the Leo trio itself. Get right into here. Let's see, try and pick a middle spot here. Try and get all 3 of them, which I should be able to do, but this is a pretty cool group here. Okay, okay, there's 1 and there's 2, and okay, and there's 3 up there. Okay, well, let me just move it up just a little bit in the view here. Come on, move up just a little bit. There we go. That's probably going to be about as good as I'm going to get right there. Fortunately, the camera's 90 degrees. 90 degrees out of ideal for this one, but we'll still get all 3. And it's 3 pretty cool galaxies, so very different galaxies in here. But this is the famous Leo trio, which, which is right underneath the tail of Leo the Lion. Oh, in fact, since we just got 3593, should add that to the list. In fact, add these two while we're waiting for that first sub to come in. 65, 66, and 3628. The Hamburger Galaxy. Okay. And here we go. They should be coming in. There it is. The Leo trio. Can't zoom in much on this because would exclude one of them. Hi Jeff. The Ethernet adapter. I doubt Mark is going to produce them for sale. I think there may be somebody on. Are you on Cloudy Nights, Jeff? I believe there is somebody on Cloudy Nights who will actually make them for you if you want. I think, but they're not a commercial project. Basically, this guy who lives up in Ottawa is an embedded systems engineer, and he just kind of took it on as a project, as an Arduino project, to build these adapters to kind of fill gaps in for the okay, so you are on Cloudy Nights. So yeah, so you're aware of the Mark's threads where he does the homebrew, he calls it homebrew devices, and he basically designed them, wrote the software for them, and they're basically DIY projects, or what he calls homebrew. So he basically sends you out to buy the hardware and do the soldering, and he has the programming for them that makes them work. And he doesn't take any money for it. He just it was just kind of a pet project of his, and so he has expressed to me that he has no interest in selling them. Actually, a couple of days ago, he did put one on the Cloudy Nights classifieds. So I don't know if it's still there, Jeff, but you may want to check to see if it is still there. I believe he had an Ethernet adapter, an Ethernet box for sale that was just an extra one that he had built that he was just getting rid of. But I don't believe he ever intended to become a manufacturer and producer of those things. So I don't expect that they ever will officially come to market. I'm pretty sure there was somebody else, maybe it was DeMarco, was his username, DeMarco69 or something. He was, I believe, making them. But if you're on Cloudy Nights, you can go into the homebrew Ethernet thread, which actually I just posted in today, so it should be fairly close to the top of the Celestron subforum. You can go in there and ask somebody. You throw enough money at them, somebody will probably build it for you. If you're not comfortable doing the electronics work yourself. Me personally, the only thing I'm not comfortable with doing is soldering. I don't have the soldering equipment. Certainly not fine enough soldering equipment to do what's required to do that work. So I was happy to hit Mark up very early on, and he somewhat grudgingly agreed to make me one, and he did, and it just works fabulously. So, but I think there was somebody. I have to go back and look at the thread. I think there was somebody who was actually offering to make them. Not Mark himself, but somebody else there was. So, 3 very interesting galaxies. 2 spirals, fairly regular spirals. These 2 down here are a little bit of an odd shape on this one, but pretty much spiral galaxies. But then this one up here, this one's called the Hamburger Galaxy. Definitely an edge-on, very interesting bow tie shaped. It gets fatter as it goes out, which is a little bit different too. Normally the bulge is the fattest spot, and it gets more slivery as it gets to the outer. More slivery as it gets out to the outer reaches. But this one goes the other way around. It's got a very cloudy, thick, dense outer portion that is just pretty cool. Let's see, I think we're a little bit, yeah, we are. Let's brighten this up a little bit, maybe brighten this up a little bit, let you guys see it a little bit better. But very interesting galaxy. Let's see, yeah, just really interesting. It almost looks like just a big old cloud. The Hamburger Galaxy. Three of them together is pretty nice. Still got the yawns. I even had a nice nap this afternoon and I still got the yawns. Now in our 10th minute. See if I can stretch it just a little bit more without making it too noisy. Got a little more of those wispies to show up. Leo Trio. See galaxies. Cool, there's 10 minutes. So let's be on our way. Okay, so we did that. We can now do this, which will add those to the list. And now we can keep on moving. We'll move kind of back to the main pack here. That one's a little bit on the small side. This one's a little bit better. Let's try this one here. $38.10. We don't really have a picture, but it's right there. Let's let the mount settle for a second. Okay. And let's start the image on that. And this is 38.10. Let's see what. Spiral galaxy located in Leo. It's about 50 million light years away, which given its apparent dimensions means that it's about 60,000 light years across. It was discovered by William Herschel on March 15th, 1784. Okay. It's a spiral similar to that of M97. The central part of the galaxy disk is of high surface brightness and features tightly wound spirals. Okay. Oh yeah. Yeah. Got another one here. Little sliver of a galaxy down there. Outside this disk lie more open arms with lower surface brightness, right? See, mostly for us here right now, the blown out bright core is the inner core part. And then is the center disk they're talking, which has tightly wound spirals in here. And then the outer part, the fainter part, is the that was interesting. What was that? That looked like a yeah, it was a blurred frame. Huh. Interesting that FWHM didn't pick that up. Okay. We're gonna reset that because that second sub-exposure just completely blurred everything. It made it much more blurry, which is not what we want. In fact, I'm surprised that the filter did not eliminate that. It certainly should have. There's another streaked and blurred one. Looks like the mount is for some reason moving on me here. Alright, we'll try it one more time. Interesting, because the first sub-exposure was fine, and then the two that I've gotten since then have been blurred stars. Tracking is definitely on, so that's just odd. Not sure why it would be doing that. Let's see what this one looks like. Yeah, that's right. That's nice, tight, round stars. That's the way it should be. So let's hope it just stays that way. Not sure why we're getting some that are streaked. In any event, the bright central region is thought to be forming many new stars and is outshining the outer areas of the galaxy by some margin. Farther out, the galaxy displays strikingly rich dust clouds along its spiral arms. Hot young blue stars show up in giant clusters far from the center, and the arms are also littered with bright red giant stars. 2 supernovae have been discovered, one in 1997 and another one in 2000. Yeah, so they're talking about these bright pockets of stuff here. Hot young stars. NGC 3810 forms a small group of galaxies with NGC 3773, the NGC 310 group, which is part of the Virgo supercluster. 3773 is that. That's 3705. Not sure where 3773 is. It may have been dropped because of my filters. There's a bunch of PGCs in there. There's 3773 up there. Okay. You can see, look at all of them in here. Look at all the galaxies in there. Most of them are just too small to be interesting to our equipment. But yeah, 3773 is up here. The group that they think it's part of. Pretty little pinwheel. We'll give it one more minute here. I don't think there's a whole lot of point in doing a lot more time on this. Let me see if I can back stretch off, see if we can pick up anything in that core region. Yeah, see, you start to be able to see a little bit more in the core region now. A little bit more circular, tightly wound circular in here. Just a very bright core. Almost a thick, cloudy texture to it. Kind of cool looking one, looking at it like this actually. It's almost like a light bulb in the middle of a cloud. Pretty cool. Then you turn the stack up and you get more of the outside stuff to show up, but the core then gets really blown out, so interesting, but cool. Well, that'll do for that one. Nice little guy. But moving on. Add you, highlight you, finish. Who's next? Well, we got a whole slew down in here. 1.5 by 4. There's a whole cluster in here. Yeah, oh, that's Markarians. Okay. Yeah, let's go do Markarians. Nice cluster of galaxies in here, including some Messier objects. Yeah, there's a whole bunch of them. 1, 2, and then 2 more in there, so yeah, that will work. Okay, good. A whole bunch of galaxies in here. This is a pretty rich little band in here of stuff. Just slews of them. You look at them, they're just all over the place in here. This spot in here is just lousy with galaxies. Well, let's look M96 here. We're down. Yeah. Put a new tab. Close this one. Come here. And then we'll open this one up. So M86, which is the central bright elliptical galaxy that's in there, which will come up here in just a second. Boom. So that's kind of the core one of these. Let's in fact pick this up a bit. So you guys can see it a little bit better, but look at all the galaxies in here. But M86 is kind of the central guy. It's an elliptical or lenticular galaxy in Virgo. It's discovered by Charles Messier in 1781. It lies in the heart of the Virgo cluster of galaxies and forms the most conspicuous group with another large galaxy known as Messier 84, which is probably this one down here, I would expect. It displays the highest blue shift of all Messier objects, as it is, net of its other vectors of travel, approaching the Milky Way at 244 kilometers per second. This is due to both galaxies falling roughly toward the center of the Virgo cluster from opposing ends. Messier 86 is linked by several filaments of ionized gas to the severely disrupted spiral galaxy NGC 4438, indicating that M86 may have stripped some gas and interstellar dust from the spiral. 4438. Maybe this one? Yes. So if we flip this like this, yeah, 4438 is this one, yeah. So it's going to be that one there. Boom, 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 boom. Yeah, it's going to be this one. So it's stripping gas and things from 4438. Has several filaments of ionized gas between these two. It's also suffering ram pressure stripping as it moves at high speed through Virgo's intracluster medium, losing its interstellar medium and leaving behind a very long trail of X-ray emitting hot gas that has been detected with the help of the Chandra Space Telescope. Messier 86 has a rich array of globular clusters with a total number of around 3,800. Its halo also has a number of stellar streams interpreted as remnants of dwarf galaxies that have been disrupted and absorbed by this galaxy. So it's kind of like the big bully in the neighborhood, sort of. But definitely a lot of stuff going on here. A lot of galaxies. The Virgo supercluster. Boy, take a minute to add all these in there. I think I'm just going to add in the primary Messier objects and call it good. The eyes. Ah, the eyes. Copeland's eyes. I'll at least add all the NGC objects. Left still in here, a bunch of M objects, whole bunch of M objects down here, 4 M objects right there, some more NGCs, whole slews of things in here. Look at the whole chain of them. I mean, this whole chain of galaxies just goes all the way out. There's another cluster of them down here you can see. Quite a lot of galaxies. I mean, you can just see in this image all these. There's a fuzzy blob. There's a fuzzy spot. There's a fuzzy spot. Fuzzy spot. Fuzzy spot. Fuzzy spot. Fuzzy spot. There's just slews, which is why it's called the Virgo supercluster, I guess. Just slews of galaxies in here. Yeah, we just lost a sub. Yeah, another. Looks like another streaked one. Well, finally, the filter took it out, which is what it's supposed to do. Boom, that one came in. That was good. That's what it's supposed to do, is take out the bad ones. Whole mess of galaxies in one shot. Hey Pete. How are you doing tonight? Thanks for stopping in. Got a whole mess of galaxies on the screen at the moment. Definitely a whole mess of them in here. Just focus down here on this, focus down here on the bottom left corner. And just see how many are in here. All the little fuzzy spots that are down here. That's kind of an interesting little, kind of sharp oval on there. That's a nice sharp looking galaxy. Fuzzy ellipticals. And then these two are just probably interacting and pulling each other apart, which is why you get these weird cloud structures. There's a nice little spiral with a dust lane right around it. Huh. Fuzzy spot, fuzzy spot, fuzzy spot, fuzzy spot, fuzzy spot, fuzzy spot. Fuzzy spot up here. Good morning, Ollie. Yeah, you're late today. Gosh, you were here right off the bat yesterday. Must have decided to sleep in a little this morning. Well, as you can see, Ollie, we're doing Markarians at the moment. M84 and 86. And a whole mess of galaxies. Yes, they are. They are super indeed. What am I going to do next? So I've got those. So many places to go. That's really small. That's okay, not great. I mean, heck, I can just... I guess we'll go out here. M88, M91, we can pretty much just Messier object hop at this point. So probably we'll just go do 88 next. Okay, that's a cool one. Let's go do M88 and the stuff that's around it next. Make sure you're not moving. Okay. Let's start the imaging. So this is going to be M88. Yeah, nice spiral. We're going to have another galaxy out here. Actually, you know what? I bet you we can do 88 and 91 together. So let's. Why do one when you can do two? Yeah, there we go. Boom and boom. Got them both together. Even better. Even better. Get them both. Two nice little spirals. You know, spent the money for that 1-inch sensor. Might as well use it to its full capacity. 88 and 91. Add. Keep you centered. All right, let's see what we got here. Yeah, there they both are. Very interesting. Yeah, M91. This is a 88 is a regular spiral. 91 is a barred spiral. It reminds me a lot of 95 and 96, especially 95. So let's take a look. Let's see what M91 has got to say for itself in Wikipedia. 91. Messier 91 is a barred spiral that is found south of Coma Berenices. It is in the local supercluster and is part of the Virgo cluster of galaxies. It's about 63 million light-years away. It was the last of a group of 8 nebulae, quote-unquote nebulae, as galaxies until the next century were not suspected to be visible. The term galaxy being used as a synonym for universe, discovered by Charles Messier in 1781. Among those few Messier objects in the catalog as the result of bookkeeping mistakes by Messier long missing, it was not until 1969 that amateur astronomer William C. Williams realized that M91 was NGC 4548, which was cataloged by William Herschel in 1784. Some sources contend that the nearby spiral galaxy NGC 4571 was considered as a candidate for this object by Herschel. The object was discovered in 1781 by Messier, who described it as a nebula without stars, fainter than M90. Messier mistakenly logged its position from Messier 58, where in fact it should have been Messier 89. William Herschel observed the same object in 1784. In 1969, Williams solved this lost Messier object by measuring its right ascension and declination relative to those of nearby galaxy M89. Notable reference stars angularly nearby are sparse, rather than M58, a ninth magnitude galaxy which Messier recorded in 1778. This amended night sky star hopping reference point matches Messier's figures to 1/10 of an arc minute in right ascension and 1 arc minute in declination, a 60th of a degree. Messier mistakenly logged its position from Messier 58, where in fact it should have been Messier 89. So he miscatalogued it a little bit. Cool. Well, a couple of nice little galaxies. Where to next? So we've got those two. Let's highlight all of our new stuff here. Yeah, so we've got all of these in here. I guess we can do... We just did 88 and 91. I guess we can do the middle. Do 90 and 89 next. If we target that star, we'll bracket both of them. Okay. Let's head on down there and do those. Those guys. Nice spiral. Unfortunate alignment. They're doing that, but I still think we'll be able to do it. Just a little bit twisted around. But I think we can still do it. Unfortunately, they are straight up and down. They're straight vertical in my sensor, so the narrow part of the field of view is catching them, but it's still enough. I'll be able to get both of them in. Looks like 89 is just a regular old lenticular elliptical. But 90 looks like a really nice spiral. Well, we'll see in about 15 seconds here. Yeah, that's a pretty spiral. That is just a 90 is just a pretty little spiral. And we got another nice little one over here too. So what's for breakfast this morning, Ollie? Is it ham and bread again, or doing something different this morning? Actually, must be kind of interesting for you sitting there watching this when you're looking back in time, sitting there with your Sunday morning coffee watching somebody live doing their Saturday night imaging. Kind of interesting perspective. Live, but looking back in time. 90 is just nice looking galaxy. Look at that super spiral. Oh, you haven't figured out what breakfast is yet, huh? Okay. Time travel indeed. Today is a great day in space travel. No, enlighten us. We crossed some, is it today some sort of anniversary of something? First flight on a foreign planet. A foreign planet, huh? Why, did something happen on Mars today? The only planet in the known universe solely inhabited by robots. The character of the Martian space probe will fly today for the first time. Cool. That is just a fun looking galaxy, that is. Three big galaxies in here, and then a whole bunch of little ones. Fuzzy spot, fuzzy spot, fuzzy spot, fuzzy spot, fuzzy spot. Whole bunches of them. Coolies. Alright. Gotta add these. And add these. And what's next? Guess I didn't do well, I guess we'll start down and work our way back up. Active galaxy. 4654. That's 4710. That's very small. We won't worry about this one's bigger. And it's an active, so don't have an image. Let's see what we can see what our first sub-exposure brings up. Oh yeah, there is a smudge, and there's another one right here too. I can already see. Okie dokie. Let's see what this has to offer. 4654. Stellarium doesn't have anything. 4654. An intermediate spiral, 55 million light years away. It's a member of the Virgo cluster that shows peculiarities in the distribution of both its atomic hydrogen and molecular hydrogen, as well as an asymmetry on the distribution of its stars, with the atomic hydrogen being compressed in the galaxy's northwestern part and forming a tail on its southeastern part. Yeah, definitely a galaxy there, certainly there. Another one up here. Almost looks like it's being blown by a solar wind. Yeah. So that's what they're talking about with the compression. While interactions with the Virgo's intra-cluster medium, that is, stripping NGC 4654 of its gas as the galaxy moves through it, can explain its gas distribution. It's unable to explain the peculiarities on the distribution of its stars, having been proposed that NGC 4654 interacted with its neighbor, the spiral galaxy NGC 4639, about 500 million years ago, producing this event, the latter phenomenon, while experimenting until the present day, weak ram pressure stripping due to its motion within the Virgo cluster. That's an awkward sentence. Anyway. Despite suffering a loss of its neutral gas, NGC 4654 does not suffer the deficiency of it that show many spiral galaxies of the Virgo cluster. That's written wrong. And also has the star formation typical for a galaxy of its type. Well, I think it's moving through some sort of the medium. It's causing it to almost look like a wind-blown effect, where it's moving, left to right here. And this galaxy out here has a couple of interesting spirals too. There's a nice spiral arm there. This one's not quite so clear. It's a little bit broken up here. I should get some Ricola drops for my throat. I do have some, actually. Problem is, this is more spring allergy than anything else. Yeah, I actually have some in my bathroom cabinet. But I think the slurping and chomping would be worse than the intermittent throat clearing. But it's just a spring allergy thing. Apologize for the noise though on the mic. I'm sure the mic is picking it up very, very well. Couple of interesting little galaxies though. I think 5 minutes on those is good enough. Did I add this yet? No, I did. Okay. Now 4710. It seems to me I already looked at that. I decided it was too small. It is. These two I think I can probably do together. See if I can't. Maybe there's a star right there. See if I can't get both of these together. Oh, I should say all three of them together. Okay, there's 58. Okay, so these three here, I think are these three. Oh, duh. Zoom all the way out there, genius. Okay, yeah, there's one there. There's more there. There's another one there. There are so many galaxies in here. I don't think I'm going to successfully figure out which is which. There are so many galaxies in this image, so we'll just start it going, and I'll assume we're going to get all of them. We should certainly be able to fit them in there. Just a question of how the scope, the field of view is oriented. The Siamese twins. Yep. Or fish and chips. That's kind of fun. 58. Might as well mark you down there. Got all of you guys. Another 10 seconds. We'll see what. See what we can see. Whoa, it ignored the frame. Not sure why it ignored that frame. Okay. It was too fuzzy or blurry somehow. The mount may not have been completely settled. So we just have to wait for the next one to come in. Barely got it in again. Slightly unfortunate orientation. There's the Siamese twins down there. Bonus galaxy there, and there's M58. Just barely got it in. Again, unfortunate orientation. But we got them all. Nice little galaxy right here in between them. Surprised it's not listed in here. It's almost the same size as the Siamese twins. 4568, 4567. 567. NGC 4567 and 4568 are the butterfly galaxies, or Siamese twins, are a set of unbarred spiral galaxies about 60 million light years away. They were both discovered by William Herschel in 1784. Only one supernova in 2004 was discovered in the butterfly galaxies until March 31st, 2020, when the Zwicky Transient Facility detected the rapidly rising supernova 2020 FQV. These galaxies are in the process of colliding and merging with each other, as studies of their distributions of neutral and molecular hydrogen show, with the highest star formation activity in the part where they overlap. However, the system is still in an early phase of interaction. Huh, cool, so these two are actually colliding. They're actually beginning their collision. Just starting to. That's pretty cool. Oh, and the one that's in between them is 4564, huh? It must, it just falls out of, I have it filtered out in Stellarium. It's probably just too small or too dim. But these two are just beginning to they're just beginning to collide. and lots of star formation is occurring right in the spots where they are overlapping. So that's kind of interesting. There's a lot of high energy stuff going on there. Yep, and we're going to collide with M31 soon. I think you'll be about 2 billion years old, Ollie, when that happens. Wonder what you'll be having for breakfast that day. Oh, and my internet is once again... The internet looks like it just took a dive again. Looks like the internet just took a dive again. And I just lost another sub-exposure. Yep, other one just went out. Well, after being pretty solid for the first hour and a half or so, it looks like my internet is now doing the old up and down thing again. So, don't be surprised if my audio is cutting out or the image is skipping around a little bit, because I seem to be having the regular internet snafus again. Yep, the internet's definitely doing its weirdness. Once again out here. It's been pretty good so far, but now it's starting to do its crashing thing again. But this is pretty cool if these two are just beginning their collision. If we live to be 1 billion years old, we might be able to stick around and see what happens. Yeah, there is a whole set of zeros missing from that 2 million 2021. It's the year 2 giga years. It's the year 2 gig. 2 2021 gigs. Alright, well that's pretty good there. Let's see what we can see next. colliding galaxies. That's a lot of fun. Okay, highlight things because we've added everything. Okay, let's redo that. Yeah, 59 and 60. Definitely do those. So let's try that. Doink. 59 and 60 and of course a whole host of other stuff in there too. Well, let's see how that came out because I think actually, yeah, that's actually not too bad. It's a little high in the frame, but I think it's actually okay. Yeah, I think it'll work. Okay. Let's see how it works out. So it's going to be 59, 60 plus bonus galaxies. The one that I'm on, for starters, and then there's a 60 has a companion here. Obviously another one here. Looks like a bunch of ellipticals, so not a whole lot of interest. This one actually might be the most interesting one. Who knows? We'll see what we got. We'll know in 30 seconds how well it comes out. Yeah, look at all of them. Wow. Yeah, okay. Yeah, so there's, 59, 60, and the one we're focused on, which is the 4638 is there, and it has a companion galaxy. These have companion galaxies. These two are companion. Everybody's here is made it up. Another whole big old group of galaxies. And that's why they call this galaxy season. A whole bunch of them here. Whole bunches of them. Whole bunches of them in here. Yeah, you are. Oh, you don't need to worry about adding that. Definitely chewing through them. We've done a lot in the last few. I mean, look at that. They just keep going right past Virgo. That just means they'll keep rising later on. Next month, all this stuff will be probably about dead overhead. Yeah, there's a bunch more out here. All right. Definitely pretty spectacular, though. Lots of galaxies in this image. Okay, well, I guess we'll go do that next. It's a named galaxy. I guess we'll go do it. That one's pretty small. Cool. Nice little chain of galaxies there. Alright. Let's go see what the paper kite galaxy is about. Looks like a regular old elliptical. Got a nice little slivery spiral in here. Let's see what we can see. $47.62. NGC 47.62. 7.62. There's an edge-on lenticular in the constellation Virgo. It's about 60 million light years away. The edge-on view of this particular galaxy, originally considered to be a barred spiral, makes it difficult to determine its true shape. But it is considered that the galaxy consists of four main components: a central bulge, a bar, a thick disk, and an outer ring. The galaxy's disk is asymmetric and warped, which could be explained by NGC 4762 merging with a smaller galaxy in the past. Yeah, so it is kind of warped a little bit. Interesting, though. Interesting shape. The remains of this former companion may have settled within NGC 4762's disk, redistributing the gas and stars and so changing the disk's morphology. It contains a highly energetic central region. The nucleus of the galaxy is detectable due to its particular spectral line emission, allowing astronomers to measure the composition of the region. NGC 4762 forms a non-interacting pair with the galaxy 4754, which I guess is this, yeah. So it's this other one here. Yeah. So they're calling these a non-interacting pair. Okay. What about 4216? There are 3 interesting galaxies together. 4216, huh? Let's mark these. The Paper Kite Galaxy. And so you're saying 4216, huh? See 4216. 4216. Oh yeah, the silver streak. Yeah, we did that. Did we do that last time? I think we did that last time. Yep. No, I think we just did that tonight. We did that right before Markarians. We did that on the way down, I think, from blow dryer. Gosh, I don't remember. I don't remember if we did that one last time or this time. We could have done it either way. I do not recall. But in any event, we have definitely done it. Yeah, I'm thinking we... I don't remember if we did it tonight or last time. Were you here for the whole session last time? It seems to me you were here at the beginning, but then you weren't here at the end. So we either did it at the end of last session or the beginning of this one. And I don't remember now which which was which. That's a pretty interesting looking galaxy, though. So very stark. And just a very bright and sharp. And seeing if I back off on the stretch, you get a little bit more granularity, but not much. Interesting looking, looking things. In any event, I think we can move on from that. So let's highlight them because we've added them. And work our way back up here. Yeah, maybe. take a look at that one. It's a little on the small side, but it might be okay. Yeah, there it is there. Let's see what it looks like. You left at the end last time, so you were here for the whole show last time. So then, well, I don't know. One of the two of us, either you forgot that we did it last time, or I forgot that I did it this time. I don't remember. Alright. We got it here. Yeah, I don't think we have a name. Yeah, I've got the list. Well, actually, you know what? Do I have the date on it? Yeah, you know what? I haven't been putting the date and time. So... Silver Streak is way back here, which means it's been reordered. Yeah, I did not check. I have not been checking it. The first couple of sessions I did check the date and time. Since then I have not. So, yeah. I don't know what date it was. Yeah, there they are. Look at that. There the two of them are. Actually, the two. I only knew about one. I say two, but I only knew about one. But there's two of them in there. Definitely a bonus. A couple of barred. Looks like barred ellipticals. Oops. Whoops. Wrong window. That's not the one we might be looking at. Yeah, a couple of barred ellipticals. Almost TIE fighter looking kind of deals. If we can. Yeah, just a couple of nice barred ellipticals. Not much more to it. Cool, that's about 5 minutes on that. So that's good. And we've had that in there. So now we'll head back up here. 4429. Yeah, that one will work. Yep, right there. Alright, let's see if this one is worth spending much time on. $44.29. I think what I'll probably do is we'll do 4330 here. How big is 43? Oh, 4330 is too small. So maybe we won't do that. But M87. M87 looks like a plain old elliptical, so that may not be terribly exciting to do. But M87. We'll take a quick look at it. This one's just looking really small, so I don't think it's going to be much to do. Oh, nice little spiral. I'll give it a couple of sub-exposures. We'll do one more minute on this guy. internet's doing little wonky things again. So I think we'll probably just do M87 and call it a night. Well, there's a 5 minutes. So that's probably about good for this guy. And we'll do M87 and call it good, I think, for the night. And did I add this already to the... I did not. Oh, no. I'm on the wrong target here. No, I can't get it. Come on. Okay, now you need to come up here. You need to be removed. I did not do you. I did you. There we go. Okay. So now, I was going to go over and do M87. So let's do 87. Which I think is just going to be a little elliptical. Let's let the mount settle for a few seconds there. And I think M87 is just going to be a regular old elliptical, so I don't think it's going to be something we're going to spend a whole lot of time on. Yeah, it's just going to be an elliptical, but there's going to be other things in the field here. So there's several other galaxies around, so we may be able to spend a couple of minutes looking at it, but I think this will be my last one of the night tonight. Which we've done quite a few, including quite a few tonight, so made some good progress on our goals. And I'm thinking there probably will be one more session early this week, but always weather dependent. We'll have to see what happens. You never know what it's going to be like for the week. I could try astroperic. Astroperic works, but yeah, this is just an elliptical. There are a few other galaxies around, but this is just... Ooh, that's actually a nice little spiral down there. Possibly a barred spiral. What is going on here? Go away, go away, go away. Yeah, see, tomorrow night definitely got some clouds going on. Monday night, possibly. Tuesday night's looking better, but wind. So Monday night, maybe. It's looking okay in terms of clouds, but we'll have to see about the wind. So that's a possibility. It's a possibility, but then moon sets at 8 o'clock. Moon sets at 9 o'clock on Tuesday night, so could do a 9 o'clock session on Tuesday night. And then by Wednesday night, the moon sets at 10 o'clock, so it's starting to get a little late. So possibly a Monday or Tuesday night, maybe. We'll have to see. We'll have to see. But yeah, there's M87. M87, which is a regular old barred spiral, or excuse me, a elliptical. Virgo Galaxy. Virgo, a smoking gun. Okay, 4486. Let's see what 87. M87. Is a supergiant elliptical galaxy with several trillion stars. Wow. Okay. So this one is fairly unique. Oh, and this is the one with the jet. Okay, this is an interesting one. One of the most massive galaxies in the local universe, it has a large population of globular clusters, about 15,000, compared with the 150 to 200 in the Milky Way, and a jet of energetic plasma that originates at the core and extends at least 1,500 parsecs, about 5,000 light years, traveling at relativistic speed. It's one of the brightest radio sources in the sky and a popular target for both amateur and professional astronomers. Several trillion stars. That's just awesome. I don't know that we're going to be able to see the jet. There is an energetic plasma jet that comes out of it, and I don't know if we're going to be able to see it. If I unstretch to get rid of the glare of the core, then we lose the ability. Of course, I'm getting a little bit of streaked star action here again. So the mount is moving slightly again on me. I can't really tell from I don't really see the jet in here. I wonder if it takes a certain filter to be able to see it. I definitely do have other stars in the picture, and there is a Unlike a disc-shaped spiral galaxy, M87 has no distinctive dust lanes. Instead, it has an almost featureless ellipsoidal shape, typical of most giant elliptical galaxies, diminishing in luminosity with distance from the center. The stars have a nearly spherical symmetric distribution. It has an active, supermassive black hole at its core, which forms the primary component of an active galactic nucleus. The black hole was imaged using data collected in 2017 by the Event Horizon Telescope, with a final processed image released in April 2019. In March of 2021, last month, the EHT collaboration presented for the first time a polarized based image of the black hole, which may help better reveal the forces giving rise to quasars. Its galactic envelope extends to a radius of about 500,000 light years, where it's truncated, possibly by an encounter with another galaxy. Its interstellar medium consists of diffuse gas enriched by elements emitted from evolved stars. So, yeah, I don't know which, where the jet would be. There is a relativistic jet that comes out of it, and it might be. those two stars? I'm not sure. Let's see, there is a Hubble image of it here, but it's hard to tell from the Hubble image. It's hard to tell, relatively speaking, how small the image scale of the Hubble image is, and trying to compare it to the stars that I have in this background to its stars. It's kind of hard to tell. Still a galaxy with several trillion stars. It's probably about 5 times the size of our galaxy. In any event, I don't see anything resembling the relativistic jet that's coming out of its core. I never really have been able to image it. Never have been able to really. These are just hot pixels marching across the screen, so that's nothing. These just look like stars to me. So I don't really see the jet. Nope, I don't see it. In the event, that's 10 minutes, so I think I am going to call it a night. Call this one done. So thanks everybody for joining me. Like I said, I think I will probably be doing another one here. One more session, probably getting in before the moon shows back up in the sky. Lightens the sky up here. So probably be doing one here in the next 2 or 3 days. So stay tuned for that. And in the meantime, hope everybody has a great night. And thanks for stopping in. I appreciate it. And I will see you next time. Good night, everybody.